Well, thank you very much. Appreciate you coming to our breakout session here. You know, this presentation will obviously be about emerging technologies. We're not going to go into a lot of depth, right? We're covering five within 60 minutes. So my hope is that, whatever I share here will maybe light a spark for you that you can take back to your team and hopefully, come out with something good out of it. So. Before we go into the technology, I'll share a little bit about myself. As Mark said, I've been a convene member for I think it's 8 years now. I feel like I've been saying 8 years for a number of years, so maybe more than that. I'm a part of Rick McCarthy's group. We're group 711. We're 711 because we merged two groups. Group 7 and 11, I guess we couldn't agree and compromise on a new number, so we did the 7/11 thing. That's right. You guys, you may hear a little bit of an accent in my voice. That's because I'm Eastern European. I'm Romanian. I escaped with my family, communist Romania, back in 1988 with the help of an American missionary. We did this Sound of Music thing without the music or the Nazis, where we crossed borders into Yugoslavia, Austria, Germany. We lived in a refugee home for about 2 years in Germany, and finally, we're able to make it here in the United States in 1990. You know, life was hard for the first few years, but I'm sure you guys experienced the Cold War. What I can share with you the perspective about America from the other side of the curtain. We felt like America represented everything that was good about the world, even though we were on the other side. So just being here was just a huge blessing and an opportunity for us. And even though life wasn't great, we were totally jazzed to be here and really build a life for ourselves. And fast forward, about 13 years later, my business partner and I started TechMD. It's just totally bootstrapped, self-funded. It was just him and I for a number of years, and then we, had the courage to hire employee number one, then two, and today we're at about 50 employees and doing well. In fact, just last week, Clutch.co, which is this verified review site, rated us as the number one IT solutions firm in the LA region. And so we're doing well and enjoying ourselves. So that's my story. I'm sticking to it. Let's get started with the 5 emerging technologies. What better way to start a talk about technologies than to look at some old artwork? So here's a piece that shows what life was like in the 14th century. It's called the Allegory of Good and Bad Government. Here's another one that shows what life was like 200 years later in Italy. And this one's called the Opening Ceremony of Palio in Siena. Here's the last one. This is maybe a more familiar painting of Venice. And this is how Venice looked like in the 18th century. And the reason why I share this with you is because I want to kind of draw a contrast and sort of showcase what technological progress has been over the last couple of years. So we're looking at a 200-year span between each of these. If you look at 14th century, you look at 18th century, there's certainly some difference there, just superficially speaking, right? We're just looking at pictures. But the difference that we see there pales in comparison to what we see in 21st, when we put 21st century Dubai here, right? So huge change, huge progress, particularly when you consider all these things that we accomplished in the 20th century, right? We've sequenced the genome, landed on the moon, harnessed the power of the atom, right? So really just amazing things. So if you look at this very unscientific chart, don't hold me to it, it's totally unscientific. You look at progress over time, over the centuries, so there's almost no technological progress. And then all of a sudden there's this uptick, and that puts us where we are today, where that blue guy is standing. And as human beings, we sort of forecast the future through the prism of the past. And we probably expect that, hey, continued progress would look something like this, kind of a comfortable rate. Whatever's been happening now will continue to happen. But there's some evidence that suggests that there's a possibility that just maybe progress as a result of some of the technologies that we're going to talk about today will be a lot more dramatic than that and will look something like this. So the question is, what do we as business folks have to do to potentially be prepared for a change like that. In fact, that change has a name, and it's called the Fourth Industrial Revolution. You know, we've started out with mechanization of water, power, and steam. Then we've got mass production, right? The forge, assembly line, and so on. Then the revolution that we all pretty much have lived most of our lives, right? That we've been mesmerized by, which is the computer and automation. And now we're really entering the fourth, which is really the integration of the physical world and the cyber world together with data as the glue for it all. So with that in mind, let's start with technology number 5, all right? So this is kind of a countdown. I'm starting with maybe the most sensational technology and down to the most practical technology. My hope is that that won't cause my presentation to just fizzle out, right? This is probably some of the most exciting technology that's out there. So let's talk about machine learning and AI and what it does today. So this is what we've probably grown up with, right? We've all seen these movies and, you know, Terminator and 3CPO and HAL 9000 and all that stuff. That's not where we are, and that's probably not where we're going to be in anytime soon, right? We're not talking about consciousness when we talk about AI and machine learning today. What we're talking about is the ability for machines, computers, and software to simply learn. And let's watch this movie that'll describe what machine learning is.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognize a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organizing it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing.
All right, so that's machine learning. And why is it a big deal? It's a big deal because it turns out that we as humans know a lot more than we can actually communicate and express. Just consider the task of maybe writing out detailed instructions on how to ride a bike. And I'm not talking about general advice. I'm talking about how to do it in all sorts of conditions, on rough roads, on smooth roads, uphill, downhill. It's an impossible thing to do. Yet this is how we write software today, right? We actually code and tell it exactly what to do, when to do it. And that's worked out great, but there's a real limitation of what computers and software can do with that approach. What machine learning does is it really allows computers to have superhuman ability when it comes to doing very narrow tasks, like identifying and detecting fraud or diagnosing disease like skin cancer. And we'll look at some of those examples. So let's take it down to the practical. You know, what can it really do today? Because I think there's this abstract sort of understanding what AI is. Well, There's been progress in 3 separate areas. Progress in natural language processing, and we're experiencing this in our day-to-day lives. You know, Siri, you've got Alexa, you've got Google Assistant. They've made huge strides, and in fact, the error rate has gone from 8.5% to about 4.9% in terms of, you know, understanding human language. And this is, by the way, in a lab environment. What's interesting is that the human language processing error rate is 5%, so it's reached that level. Although in real life, the reason why oftentimes it doesn't work the way that we want it to is because there are outside conditions like wind, background noise. So that's what, you know, machine learning and language acquisition hasn't yet figured out as well. The next area that's made a lot of progress in is computer vision, face recognition. And we see that, you know, with Apple's Face ID. We see security systems now that provide access control to secure places using Face ID. And that's gotten dramatically better. You know, error rate from 30% down to 4%. And in fact, you know, that's as a result, and really all of this advancements that we've seen in this field have come as a result of a new approach to teaching machines, which is called a deep neural network that uses a vast database of pictures, about 36 million pictures, to teach computers how to recognize faces. And these are some examples of sort of what the computer has to parse, right? So what's a puppy, what's a muffin, and what's a scone, right? So the computer is able to learn how to recognize those by getting all the sample data that's already tagged properly. You know, that's a dog, that's a muffin, and it looks at millions of these images and is able to learn what is what. So that's machine learning. The other area that machine learning and AI has made tremendous progress is in predictive analytics. So looking at historical activity, it could be transactions, and then predicting future behavior, right? The most lucrative field here, and it's probably the most lucrative field in terms of AI and machine learning overall, has been in ads. So Google and Amazon right now, what they do is they use machine learning to look at your internet activity, searches, purchases, and so on. And with that information, they predict what sort of ad you're going to click on, you know? So Google makes money not when they put an ad. They make money when you click on that ad, right? So by using this technology, they're able to predict what ads you're likely to click on. And we're not talking about, you know, huge certainty, right? But when you're looking at the scale that Google operates at, an increased likelihood of you clicking on it by about 5-6%, is millions and millions and millions of dollars. So those are the 3 areas that have made you know, great strides when it comes to AI. Let's take it down even further, because I really want you guys to walk away understanding what AI could potentially do, maybe for your business. It's all about input-output type transactions, right? So it's about voice recording, transcripts. If you happen to run a call center or something like that where you need to transcribe voice, you know, language, you know, and you do thousands, millions of those things every day, you know, there's an opportunity there. It's about, you know, photograph, you know, identifying what's in a photograph and create a caption as a result. You know, obviously, you know, Google is doing a lot of this, right? You can put in a photograph and it'll tell you what's in it, and so on. So it's all about input, output. It's not these sort of abstract, sort of strategic processes. It's very direct. It's able to cut cost and help you do more with less. Let's look at some companies out there that are having a lot of success to just highlight, you know, how this stuff works. So Tesla, they've got their autopilot. Anybody own a Tesla in here? All right, good. I don't dislike anybody then. I like everybody, because I really want one, but my wife won't let me spend the money for it. All right, so Tesla, they've got their autopilot system that you know, is probably the leading autopilot system in the world. There are many ways to drive a car and use autopilot, and one of them is LiDAR, which is this laser that looks what's around you. Tesla has taken a different approach. They use simple cameras to see what's in front of the car, and they use machine learning to understand and process what the car is seeing, and as a result, the car is able to make decisions. What's interesting about Tesla, and this is unique, I believe, to all other car manufacturers that have autopilot, is that when one car learns something, it adds to the database for all the other cars. So when one car gets better at driving itself, really the entire fleet, the Tesla fleet, gets better. And we're seeing the results. It's certainly not problem-free, but it leads the pack without a doubt. This was a story on 60 Minutes, probably about 6 months, maybe a year ago. I was surprised to hear that there are about 8,000 cancer research papers that are published each single day. I mean, it's a mind-numbing amount of cancer research papers. There's no doctor or teams of doctors that can process so much information. And the unfortunate reality is that it's very possible that there's a cancer patient somewhere that might die prematurely because the doctor's just simply not aware of a treatment that's available to them, right? So what Watson, this is IBM's Watson system, is able to do is it parses all of these documents, all of these cancer research papers in real time and understands the patients that are in its database, and as a result is able to suggest treatment for these cancer patients. So again, it's about processing a tremendous amount of data and suggesting treatments. JP Morgan, this is a quick one. They're able to review commercial loan contracts, work that used to take about 1,000 hours for loan officers. Now it takes a number of seconds, and I believe this is per year. So the question is, as a business owner, what do you do with all this? Well, the easiest thing that you've got to do is you've got to digitize your data today. Even if you don't do anything about AI, machine learning today, you've got to make sure that your data is digitized and captured. If you're doing anything on paper, you're going to be lead-footed because AI today and machine learning really uses your data as a basis to make decisions, right? So the point where you'll implement a machine learning type of a solution, you'll need data. This is a rule of thumb that Andrew Ng uses. So Andrew Ng is probably one of the leading minds on AI. And the rule of thumb that he uses to kind of explain what could be done by AI is anything that a typical person can do with less than a second of thought can or will soon be automated. So less than a second of thought is not much, right? It may seem trivial, but if you think about it, there are people that have, their entire job is just a string of split-second decisions, right? If you look at a security guard, for instance, if he's looking at surveillance video, right? The first thing he'll do is, is a person on that screen? Split-second decision. Is that person doing something inappropriate? Split-second decision. Is that a person that, might create trouble? Is he a known troublemaker? Split-second decision. So you can string these together and potentially have them done by an AI solution. And finally, you absolutely have to pay attention to what's going on with AI. It's a very real thing in your industry, in my industry, and we all need to be aware of what's going on. So I've included some resources here. There's a handout there that includes resources. There's training on a number of places. Training is become very big for AI and AI software. There's talent that you can find. Although it's in very much short supply, but some of these websites provide that. And AI, the actual technology is very much democratized. You don't have to own a supercomputer to actually use it. You can go to Microsoft's AI platform through Microsoft Azure or Google Cloud, and you can actually buy that horsepower. You need your data, but AI and machine learning is available to you today. Just one more thing. So a study was done by Oxford University and Yale University that asked a few hundred AI scientists to project, when AI will be able to exceed human performance. And these were some of their answers, for some random sort of activity. Again, this is when can AI or a machine do a task better and cheaper than a human. And you're looking at folding laundry, 6 years, truck driver, 12 years. This one was interesting. Surgeon, 37 years. Pretty sophisticated task, but that's their prediction. Curious, any sort of application, do you guys, in your businesses, do you see any potential for, what you've seen so far? Any relevance to your business and your lives? Right. Right. Right? Yeah, that's exactly sort of in the mainstream of what AI can do. Yes, Rick? Yep. I think it's probably on there, yeah. All right. Any questions? Yes.
Yeah, just so I don't know if it's out there yet, but analyzing consumer response to advertising online.
Yes.
And automating the migration of your marketing costs.
Right. And that was actually one of those lists, you know. Yeah, it's interpreting that behavior and forecasting it. Absolutely. All right, so let's move on to the next technology. We're on a tight timetable here. So it's blockchain. Let's watch this quick video here.
This is the seller. This is the buyer. This is the middleman. Cutting out the middleman can be a great thing, unless you're the middleman. And there are a lot of middlemen or intermediaries out there. Entire industries, such as payments or securities clearing, have evolved to rely on them. Why? Because they establish trust where there is none. They establish ownership, that the seller has the right to sell what's being sold. They attest to history, that there is a clean transaction history. And they certify ability, that the buyer has the money to buy it. All pretty critical details when you don't know the person on the other side of the transaction. Intermediaries know and trust one another. Their business is based on it, so they have more to lose than gain from breaching that trust. But what if there were a better, cheaper middleman? One that didn't add as much cost, complexity, and chance for error? There might be. It's called blockchain, and it has the potential to disrupt the entire ecology of intermediaries. It's a distributed ledger that relies on large networks of computers that redundantly encode transaction data by solving complex mathematical equations. The secure ledger provides an inviolable record. If the history of an instrument is incorruptible and available to all parties, there's no need for a third party to vouch. Blockchain is proof of ownership, history, and ability in non-centralized encrypted form. It's fast, transparent, and free of error. The question is not whether blockchains can cut out the middlemen in complex transactions, but rather which middlemen and when.
All right, any middlemen here? Right there, any others? We're all probably middlemen to some extent. All right, so this is a pretty difficult concept, so I want to just make sure that we're all on the same page. The blockchain is an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions, but virtually everything of value. So it's a way to record data, information in a way that's incorruptible and available to the people that you want to make it available to. And I want to make a point here. So blockchain is very much associated with Bitcoin. They are not one and the same. So Bitcoin is an application of blockchain. Blockchain is simply the technology that Bitcoin uses. But blockchain can and is being used independently. That's an important thing to know, particularly since not everybody is a big fan of Bitcoin. So there are many applications to blockchain, but I want to focus on one that's specific to maybe what we as business folks do. And it's called smart contracts. Let me just paint a scenario for you. So I've got, oops, excuse me, I'm not going to do that. I've got an IT solutions firm. What is your name? Dave. It's nice to meet you, Dave. So if Dave has a company, he's looking for an IT solutions provider. You know, he's going to maybe go online, ask some questions, make some calls. If Dave stumbles over my company, you know, maybe we'll do the sales thing. If he likes what we have to offer, you know, we'll sign a contract, you know, that says we've got to do this or that. But then after that contract is signed, we both start hoping, right? So Dave is going to hope that I'm going to provide the customer service that I'm telling him that I'm going to provide, that I'm going to respond as quickly as I'm saying that I will respond, and so on. And you know, as the IT solutions provider, I'm going to hope that, you know, Dave's going to be, you know, fairly reasonably easy to work with. I'm going to hope that he's going to pay me when he says that he's going to pay me. but there's just a tremendous amount of hope, right? So what smart contracts do is it really removes the uncertainty from these transactions. And you can, it does it in a way that leverages blockchain. So what smart contracts allows you to do is it allows you to code all of the conditions that are in a contract in a software solution. You know, the customer service has to be 95%, response time has to be 30 minutes and so on. And then the contract itself governs the entire relationship and issues funds to me when I've accomplished my goals and objectives that are outlined in the contract itself. So there isn't this, hey, Mary, call, the AP lady, get my money, or, Dave's not gonna tell me that, hey, you're not meeting your obligations, you better step it up. The contract governs that whole thing, and it governs it through software. Now, sort of, this may be overkill for a relationship like this, right? When there's a network of people, we know each other face to face, there's trust. But imagine what removing that uncertainty may do if you have to do business with somebody that's overseas, that you absolutely don't know, that you have never met, and in a legal system that you're not familiar with. So the blockchain and smart contracts in particular, have the ability to remove all the uncertainty from these business deals. I want to pause here. Am I doing a decent job of explaining what smart contracts can do? Any questions? Still a bit fuzzy. All right, I appreciate that. So it's about having software govern the entire process of ensuring that goals are being met by the supplier and that funds are being paid by the customer automatically without intervention. So my software system would issue our response time automatically, the specific numbers to the smart contract, and it all would happen automatically. Yes? Mm-hmm.
So, as an example, this week we just finished an acquisition, or cost for title and legal and escrow and lawyers and documents was, close to $500,000.
Yeah.
And the middleman.
Right.
But within that, there's no perfection. In other words, it's not a 0 or a 1. There are degrees of separation. Title. Example, if on the title report, this property over the last 15 years, somebody was 6 inches in with their fence, encroaching.
Right.
Exception. So, you can toss that away, you can use something else. Do they put in tolerances in these things, plus or minus?
It's software. So the way that I'll share, if you wanted to build smart contracts today, there's a provider that does that, and you've got to hire a developer. It's actual software that you write that basically writes your smart contract. It could have tolerances and really anything that you need. It's not a form that you fill out. It's a software solution that you build out.
How will it know that you provide the service?
So it would be integration with our software systems. So there's some compliance stuff, right? So I've got a software solution as a provider that tracks my customer service numbers and my response time. So the smart contract would integrate with my system and would pull those numbers into the smart contract without somebody typing it in. Jeff. So that's a feature of the blockchain. It allows you to share the information that needs to be shared, and it allows you to keep private the things that need to be private. Now, I want to make one thing clear. This stuff, this is emerging technology, right? It's got plenty of issues to work out. We're painting a picture of what could and probably will be at some level. Yes, Philip. Yes. Yeah, I'll share some. In fact, thank you. That's a really great transition. So let's look at some implementation of blockchain. Thank you, Philip. All right, so this is a website called 5 Miles, and this is basically a marketplace for selling used goods. I intentionally picked something that's not really high level and complex. This company allows you to sell your stuff out of the garage, right? So what they're doing is that they're using blockchain and have developed a smart contract that allows people to make transactions, sell used stuff peer-to-peer without having the concern that, and shipping it, by the way, without being concerned that stuff's not going to get to them because they're not dealing with a reputable, organization. So that's one implementation on blockchain and smart contracts. 5miles.com. They call it Cyber Miles. Yes, Philip? Okay, good. I'll share another one. So this is very real, and this is not about smart contracts, but this is about blockchain itself. So again, it has the ability to track data in a way that can't be modified. So IBM's blockchain solution called TrustChain is now being leveraged by a consortium of precious metals and jewelry stores, big players that allow them to essentially track the origin of diamonds and precious metals all the way to the mine. And in the jewelry business, this is important, right? You want to know that you're looking at a diamond, and then even if it's a great diamond, if it's a blood diamond, that's not something that you want. So that's a very active implementation that's seeing some success. Finally, this is an organization called DNVGL. It's a Norwegian company. If you've done ISO 9000 in your company, these guys are the guys that issue some of those certifications. They're moving their shipping certificates to blockchain. There's apparently a lot of counterfeiting in that business, and they're moving about 9,000 of those certificates into blockchain. There are a number of other implementations. BP uses it. It is definitely something that's actively being researched. It's not necessarily treated as a production type of a system, but it's definitely in a healthy beta phase. So I mentioned how you could create smart contracts. So Ethereum.org, this is the place, and you'll have that in the cheat sheet that I've got back there, is where you can program smart contracts. You do have to have a developer. It's very similar to JavaScript. And you can today develop those contracts. There's also a great TED Talk on blockchain. There's a lot of stuff out there. So if you're at all interested, I encourage you to check that stuff out. Any questions before we move on? All right, let's move on to the next emerging technology. Number 3, mixed reality.
Architects are dealing with shapes and spaces and light, and they dream in 3D. And then you need to translate this design into a set of 2D documents. Hololens presents a completely new paradigm. Trimble provides design solutions for architects and structural engineers.
Anything that involves getting dirty is our business. Literally hundreds of enterprises can be represented on a job site. Today, the best way those companies have to interact with each other is paper drawings. But people aren't good at visualizing 3D.
Microsoft HoloLens is a head-mounted, self-contained computer that lets you see holograms in the real world.
You get the physical model as a focus point for the team to collaborate around. And you get the hologram with the flexibility, with the ability to run quick iterations.
You'll see how we've brought in the courtyard that you suggested. You see that mouse go off the screen and into holographic space, and you're then interacting with the hologram with the mouse.
The thing that we can do for architects is really give them much higher confidence around decision making. One way we can do that is we can allow them to literally immerse themselves in the scene that they're building and see street side how the building's going to look.
Visualizing design data in the context of the real environment is a much better way to make sure that the design is implemented correctly on site.
Microsoft HoloLens allows you to collaborate with somebody regardless of distance, like they were there. Hello there.
Hey Igor, where they're trying to put this door, there's a beam behind here.
I'm looking at this beam. We're interacting with it about a problem that we can see and being able to solve that problem with all the data that we need in front of us in real time.
When I'm talking about enterprise construction, I always compare it to people trying to make music together. Each one of them is contributing to the harmony, but they all should be completely synced.
My gray hair says I've been doing this for a while. I've seen a lot of these new things come and go. And I expect in 5 years, we'll all be interacting with the world with this kind of technology.
All right, so Microsoft HoloLens and mixed reality. That video is pretty good. I don't have much more to add to that. I mean, that kind of explains. You put that thing on and you see stuff, right? It's pretty cool. So the application that it showed there is for a design firm, which seems to make a lot of sense, right? But there are other applications. So just to kind of take a step back, this is essentially combining the real world, right, with the virtual world and allowing it to operate in both successfully. Yes. Amazon, so Google did it, Google Glass, they canceled the project. Yeah, they've done it, not necessarily with the glasses, but there are many players working on that. And I'm highlighting Microsoft HoloLens because they're targeting businesses in the commercial market, but Apple, there was just in the rumor mill just last week, they're working on Apple glasses, which will be somewhat similar in some way or another. So one of these players will win out and be ahead of the pack. The bottom line is mixed reality is here to stay. You've seen what it can do for an architectural firm, design firm. Here are some other companies that are using this technology. So ThyssenKrupp is one of the largest elevator manufacturers and service companies. They are using HoloLens today because they like the fact that with HoloLens, their technicians that work in these cramped environments, are able to get access to schematics, on the HoloLens, and also get remote tech support without having to use, lose one hand, holding a phone. So obviously the phone works just fine, but in these cramped environments and, the difficulty of doing what they do, HoloLens is a good solution for them. There's a whole video that you can see there on YouTube. HoloLens has a YouTube channel that's in that sheet. But it's really, one of the niche features is that the lens itself has a camera that allows a remote person to see exactly what you are seeing as a technician. And they can annotate for you exactly what they want you to change or do differently. So that's what they like HoloLens for, and they're having some success with it. Volvo is using it during their sales process because it allows them to, highlight safety features that the car has. They can break down the car down to its bare components, and it can show scenarios, where how safety systems react through HoloLens. And Case Western University is using it to teach anatomy. Obviously, you can break it down to the vascular system, skeleton, and really understand how the body works and see it in real life. And obviously, there are other medical applications to this, right? In healthcare, imagine if MRI data can be fed into HoloLens. And have a doctor, look through your body as they're trying to find disease or a tumor or so on. So major application and potential. My hope is that IKEA will do this because my wife has maybe built way too much of this furniture and these instructions don't work for me. So hopefully that works out as well. All right, so again, not much more to say. It's an exciting thing. HoloLens is a real product. You can buy it today. It's $3,000. So it's not cheap, but it's a computer. It doesn't connect to anything. So you think a laptop's $200. You guys could be here with a HoloLens instead of a laptop and look really dorky, but it'd be a HoloLens instead of a laptop. Any questions on mixed reality? I think you heard 5 years. I think that's probably a good number. Yeah, but it's always 5 years away. So it all depends on what sort of traction it has. Do you guys see any sort of application for this type of a technology in your business? I'm curious. Yes, you might share?
I own a professional audio and video system integration company.
Okay.
And for technical support, they have to build like a data application. We have an engineer that may not understand how to fix a problem.
Right. Yeah, exactly. Yeah, absolutely. I think that's similar to our business as well. Yeah. Yeah, so an installation, you can see how it builds out, how it fits into the space that you need it to fit in, and so on. Yeah. All right, we're getting there. Let's go to emerging technology number 2. So it's getting more and more practical. Number 2 is the Internet of Things, IoT.
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data, and how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty, that the correct replacement part is ordered and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom-built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.
All right. Yes?
Of course, the downside is there really wasn't any problem with the brake line.
Yeah, no, that's right.
It was cold outside.
Of course, yeah, right. That's right. So IoT, the exciting thing about IoT is not that stuff and connected to the internet. That's almost, old school. We know that. It can be done a lot cheaper today, which is exciting. But the really exciting thing about IoT is that software platforms are now being designed to pull all that data that these sensors generate into a line of business application, car manufacturers, line of business application, and so on. So there's just an incredible increase of IoT devices. If you look here, I'll cross the table here. We're 2018 today. We were at 11.2 billion just a couple of years ago. We're going up to about 50 billion in about 20 years. So there's going to be more and more of these devices that can talk to the internet and feed data to decision makers in real time so they can make decisions. This is in manufacturing and service, in just about every single industry. Let's talk about some companies that are doing this today successfully. So this is a really cool company that I like. It's called freight farms. What they do is they've got a couple of products. One of them is called a farm in the box. They can ship that shipping container anywhere in the world, and it can really operate independently in just about any environment. It doesn't need power and all of that. But it uses IoT to manage the environment of the entire shipping container. It can grow leafy greens year-round in an optimized way. The company also provides a software platform for farmers called Farmhand. And if you're a farmer, you probably want to understand what's going on out there in the field, you know, what the acidity of the soil is, what the humidity is, what the temperature and so on. What Farmhand allows farmers to do is to have all this data coming in from their IoT devices and develop all sorts of monitoring and alerting so they have the information that they need when you need it, right? If there's, you know, a frost happening, you know, at 3 a.m. in the morning, you want that software to, you know, send you a text message or give you a call, and Farmhand is able to do that type of stuff. Barcelona, how I like to pronounce it. All right, Barcelona, they made a huge investment in IoT in 2012. They deployed about 20,000 energy sensors that manage energy and optimize it. They deployed smart waste bins, something I never thought about. It makes so much sense. What a waste it must be to send a garbage truck somewhere to pick up a bin that's empty, right? So smart waste bins tell waste management when the trash is full, so a truck can be deployed and the routes can be optimized. Parking sensors were installed throughout, you know, the whole city, and there's an app that you can use as a driver that tells you what parking spot is available. This, by the way, really drove up parking revenue for the city because a lot more parking spots are being used and not sitting there empty. Rain sensors, I don't have to explain that, you guys know what I'm talking about. All of this yielded about $150 million in savings per year for Barcelona, in savings and additional revenue being generated. You know, those are some examples, but there's just so many more applications. I mean, consider the impact of having sensors in somewhere in you know, these fire-prone areas that tell you when the conditions are ripe for a fire, or wearable devices. And this is a kind of, I'm not sure I should have even included this, because I know this happens a lot. If you've got diabetes, today you can have a device that monitors your sugar levels in real time and sends you email alerts and phone alerts. And then finally, the sensors that you guys showed in the supply chain in the video that I shared. So big impact type stuff. There is one major risk with IoT, particularly now, as it's being deployed and people don't really understand what to do with it. So you saw how many devices are being added, right? So business today or yesterday, if they had 50 employees, they maybe had 50 computers. That's 50 nodes. Those are 50, you know, things that can be attacked by a cyber criminal. With IoT, you're multiplying that maybe by 2-3 times. So you're looking at 150, 200 nodes out there that could be penetrated. So if you're deploying IoT, you've got to make sure that, you know, you understand what your security approach is to it. Any applications of IoT? Is anybody doing any of that? Do you see, is this interesting in terms of your business to any of you? Do you see any potential for this technology to be used at all? You're my friend. Right. Right. Yeah, for sure. All right, let's move on to the last technology. So cloud, number one. No video here. We'll just talk about it real quick. So why is cloud an emerging technology? I mean, you guys have heard a ton of marketing about it, and I'm sure it's nothing new. The thing about cloud is that it really is the foundation that allows all this new stuff to operate. You really can be independent of the cloud and really leverage the emerging technologies that are coming out. And in fact, you know, we're in this transitionary phase where, you know, we're moving away from the past when businesses needed to own all this hardware and complexity and risk. And this is how, you know, your typical business looked like. They had, you know, all these servers in a closet somewhere that they had to manage and maintain and so on. And we're moving into the future where by using the cloud, we can get the technology that we need when we need it and pay for it as we use it. So there's this huge transition and really quite a tremendous potential. So why is cloud important and good for business? Well, for 4 different reasons. Scalability, dependability, flexibility, and responsibility. So in terms of scalability, it allows you to grow your IT and shrink your IT as your business grows and shrinks, right? If you add more users, if you're having a good year, you pay a little bit more and you have the stuff you need. If you shrink, you can lower your cost as well. It's important. It's dependable, right? Microsoft and Google, they've got hundreds of data centers throughout the world with redundancy. I'm always shocked when we meet with new business owners and you know, when we talk about the redundancy of their system, they always believe that it's a lot more redundant and robust than it really is. I mean, consistently, you know, when they have internal infrastructure. The cloud takes care of that for you. You don't have to be in IT. You have to just focus on what your business does. The flexibility, you can add modules, remove modules, features. You know, Office 365, for instance, if you're not in it, or Google Apps, you should really consider it. There are new features and enhancements that are coming out on a weekly basis, and the cloud allows you to take advantage of that stuff without having to, you know, get a team of IT guys to install updates on your system and so on. And then finally, it's really the responsible way of running IT in a business, because it converts you know, IT spending from CapEx to OpEx, right? Rather than every 5 years guessing what you think you're going to need for the next 5 years and making this huge investment up front. And oftentimes that guesswork doesn't work out. You just break it up to a monthly operating expense. And again, you spend whatever you need to spend for the given day, given month. I want to clarify just a couple of things. There's, like I said, there's a lot of marketing about cloud. When I talk about cloud, I'm talking about the public cloud. All right, there are 2 categories, public cloud and private cloud. Public are the big players, right? Microsoft, Amazon, and Google. These guys have tremendous scale and they invest a lot of money. Azure, which is Microsoft Cloud, is really Microsoft's bread and butter today. This is what they invest most of their money in. The private cloud is kind of a small company that has decided to piggyback on the cloud marketing, and they've got some servers somewhere in a data center, and they provide a service. There are some use cases for private cloud, you know, particularly if you want more customization and you want to be a big fish in a small pond as a client. But the vast majority of the time, the public cloud is really the standard bearer, the status quo. And when I talk about the cloud, that's what I'm referring to. They've got iCloud, but it's really the consumer solution. They don't have anything for business. So the answer is no. Yeah. Now, whenever we talk about cloud with business owners, the question they invariably ask, okay, how much does it cost? And you know, there's a lot to this, but I think the bottom line is that the cloud is more for more. So you can expect to spend a little bit more, but with that extra spending, you get a lot more. The dependability, the flexibility, and so on, what I talked about. But I would argue that moving to the cloud should not be a financial decision. I think moving to the cloud should be perceived as investing in the future of your business, in large part because, as I mentioned before, in order to take advantage of all of these technologies, you really have to be in the cloud and leverage it. So we're at the end here. Parting thoughts. As I said before, I don't want to belabor this, but you have to understand, you know, you really have to be aware of what's out there in your industry and keep an eye out and read a lot. I'd be aggressive about leveraging new technologies. They are force multipliers, and of course, partner with a company like TechMD. I think that's about it. Thank you very much. Questions?